Okay, so hello everyone. I hope you are all enjoying Web3 Summit. It's still quite early. We still have a lot to cover in the next sessions. This will be a pretty short session, just 20 minutes, talking about rollups. Some of the stuff you know already, some of the stuff you are not so familiar with, so we'll see how you like it. So overall, I'll be mainly focusing on not just the implementation details, but the wider rollup technology, different flavors of rollups, how can we categorize them, what are the overall big picture weaknesses and strengths. So if there will be any questions, I will be after the session. If there is extra time at the end of the session, I will take them live, and feel free to chat up and we can discuss everything you want. Okay, so a very, very quick introduction about myself. So my name is Maciej. I'm a core dev at Parity working on Polkadot. I'm a PBA 2 Buenos Aires alumni turned into a PBA lecturer, so a full life cycle that I went through. In Parity and Polkadot, I am mainly working on how rollups, or maybe you know them as parachains, are being validated, how to make sure that if there is something wrong happening, someone is getting punished. So let's quickly look at the agenda. First, we'll be looking at an introduction, the foundation, monolithic blockchains without rollups. This is necessary for us to understand why we even need rollups in the first place. Then we'll be covering the easiest and simplest rollups called optimistic rollups. Then we'll be going into more esoteric ZK rollups with some of the complexities they have. And finally, we'll be going into something I call, and I think a few other people have already called, cynical rollups. Okay, so let's start with monolithic blockchains as the foundation. So this is the approach used by most of the old school OG blockchains like Bitcoin, Ethereum 1.0. Solana nowadays still goes very strong in this direction and doesn't want to pivot into anything else. The main characteristic of the monolithic paradigm is that every single node actually stores every single piece of information. The state is fully replicated among all the nodes. There is no major optimizations there that can really be done. The second part of the monolithic blockchain that everyone actually executes everything. If there is a transaction, if someone sends some currency from A to B, every single node, every single validator, every single miner has to actually re-execute the full transaction. And this was simply the easiest and the most naive way to get some security. This is what they went with at the beginning, a bit of an MVP for a blockchain. So what's the actual issue behind that? Everything works fine when the blockchain is simple, when the transactions are simple, when the network is pretty small, when there are not too many things happening, it can actually work very fine. It does scale to a certain degree. But as the number of nodes increases, as the computation gets more complicated, it's not as simple as, asset transfer from A to B like in Bitcoin. Things get more complicated and things simply stop scaling. And modern blockchains are really diverse. They're actually trying to target more complicated executions. You cannot run a complicated program on Bitcoin. That's why it kind of works there. And yes, we can just add more hardware, make the nodes faster. This is kind of what something like Solana is doing, but it leads to some problems of centralization, even higher entry points for actually running the node. So I'm sure all of you are aware what the trade-offs are of actually doing it. We don't want to go in this direction. We don't want to sacrifice any of the scalability, security, or decentralization. We need to find something else. Just dumping more hardware is not the way to go. So if we zoom out for a second, like maybe we can find a solution to all of that. And I very, very often heard in the past that blockchains are just like decentralized ledgers. Bitcoin is just a decentralized ledger. And yeah, that was really true for the original old school blockchains, but it's no longer true for the modern ones. Modern blockchains are actually built for programmability, for generic compute, generic execute. you don't run Doom on a ledger. You don't run Doom on Bitcoin. You run it on a different thing. You run it on a computer, on a decentralized computer. And modern blockchains are actually much closer to just a decentralized computer. So if we extend that analogy, we might find our answer. If blockchains are decentralized computers and modern computers are multi-threaded, then we need to move from the old single-threaded monolithic approach to something more diverse, something more performant, to something with multiple cores, something capable of parallel execution. We no longer can execute everything on all the nodes. This is just not feasible. No longer can everything be stored by all the nodes. So we need a system where sharding and load balancing helps us actually divert the load and do it efficiently to make the best use of the resources we are creating with the blockchains. So now that we have the foundations and the motivation, let's actually look at the first example of a rollup. And this is probably the simplest one, and it's one of the ways you can shard your network to get better performance, get better storage guarantees, and better execute throughput. So first, let's actually ask ourselves, how is the state, how is the actual memory managed in an optimistic rollup? Who actually holds it? What is the replication level? And what safety assumptions do we have? So we know that in the monolithic case, all the state lives together in this one big blob, fully replicated among all the nodes of the blockchain, of the monolithic blockchain. With an optimistic rollup, and most other rollups, the idea is to have a separate blob of data that is separate from the actual data that is being replicated on all the layer 1 nodes. And we will explore exactly, there are some pieces that are shared between them. We'll explore some of those later. But for now, you can pretty much assume that both layers have separate state trees, separate states. So L2 nodes have their own complete rollup state that's sovereign and separate. Just to be clear, that means that the layer 1 nodes are not actually holding the state of the rollup. Additionally, for security reasons, there are some pieces of data that are being actually stored on the L1, and that is mainly the call data transactions. This is the stuff you would need to replay the transactions to verify them. But in most cases for optimistic rollups, they are not actually ever used. This is a bit of a plan B, an emergency. If something goes wrong, we have a backup to verify. And this is stored in something maybe you know as the Ethereum blobs for rollups. So we already start to see a separation of roles here. No longer everyone stores everything. There are some nodes that store the rollup state, some nodes that store the L1 state. So we've discussed how the state is split, but what about the validation of transactions? How is that actually getting validated? In monolithic schemes, again, everyone re-executes every single transactions, and this is how they arrive at consensus. Pretty simple, but kind of works. What can we do here? So in optimistic rollups, it isn't really validated, at least not explicitly. Optimistic rollups kind of use the policy of innocent until proven guilty. They just assume it's okay for some time, and as long as no one else will disprove it, no one else will come with, hey, I think it's illegal, I think it's a fraud, it's going to be fine. So how can we know, and when can we know that they're actually correct? Like, when can we consider them final, and when can we use them? Generally, optimistic rollups have like a 6 to 7 days period until the transaction is fully verified on the L1. Pretty long time, and this is how much time there is to provide the fraud proof. The fraud proofs are actually coming from specialized nodes called watchtowers or validators, dependent on the specific optimistic rollup. And they constantly observe for transactions, and if they found something inconsistent, something illegal, they will provide the fraud proof. So in optimistic rollup schemes, there are three main node types. First of all, we have at the bottom the original validators of the L1. This is the standard all of you are familiar with. Then we have the specific L2 nodes called the sequencers. They are the ones gathering and harvesting all the transactions from the users and putting them in order for the L1 to consider and enact. And then we also have separate nodes that are not sequencers, either called usually watchtowers, and they are constantly observing, looking for fraud, and if they find something, publishing that fraud and collecting some bounty for it. So let's look at some of the benefits of this overall scheme. So first of all, the beauty is in its simplicity. This is the simplest rollup. It generally works. It's much easier to reason about. There are not too many moving parts. No super complicated math involved. And because the re-execution of the transaction, the revalidation of transaction is falling onto the lap of the watchtowers, it generally means that the validators from the L1 have very little to do. In general, they have nothing to do. They only need to store the DA call data in case it will be needed. But the happy path, the base case, is they don't have to execute anything. They just see a transaction, they accept it's okay, and that's it. The big downside and the most often cited critique is that it just takes such a long time to achieve finality on it. Waiting 6 to 7 days is unacceptable to most. Like, this is taking more than sending a bank transfer. Like, what are we doing? We're regressing. And let's actually look at some of those bad things. So first of all, a lot of the optimistic rollups, even though they've been around for a while, are still not fully mature. Vitalik proposed this scheme for judging how mature a rollup is. It's stage 0, 1, or 2. 2 is fully mature, no training wheels. There is not even a single rollup that's fully achieved stage 2. And what are the requirements for stage 2? For instance, having a decentralized watchtower set. Seems like a low bar, but none of them fully have achieved that. So there are some significant problems that might show up once you start looking deeper and deeper into it. Yeah, so summarizing, the biggest problem, the 6-day bridging, is just unacceptable. There are, to be fair, maybe someone will mention that to me in a second, hey, there are ways to mitigate it. You can use fast withdrawals. Yes, there are some ways to mitigate long withdrawals. The problem is there is a lot of slippage you will encounter if you do it. You're essentially taking a loan from someone else to allow you to withdraw early, and you have to pay extra for it. And it's only available for very commonly used tokens, and it has to be pretty much handmade done for every single, protocol, token, or rollup. Not the most scalable solution and not the cheapest solution. And it also allows you to only withdraw tokens. It doesn't allow you to, for instance, remotely call a smart contract. So it's very, very limited in scope. To do the more exotic interactions, you would actually have to wait the 6-day period. Okay, so now some of the uglier stuff, the bad stuff I think everyone kind of knows about. The ugly stuff is the stuff that's hidden in the docs, hidden in the stats, and they don't really want to talk about it that much. So one of the obvious one is that sequencers are terribly centralized. The biggest rollup in Ethereum nowadays is Arbitrum. They have a single sequencer that is run by them, just one. It's not the biggest problem, but it's a single censoring party. The even bigger problem is permissioned watchtowers. Messari did a report on Arbitrum, I think at the beginning of this year, and they essentially published that Arbitrum is running 13 permissioned watchtowers. And that's it. There wasn't anything else. It was just all of those 13 specifically whitelisted watchtowers looking for fraud. I see some minor problems with that. And to be fair, to give credit where credit is due, they are aware that this is a problem, and they're slowly working to fix some of that stuff. Slowly. They proposed some scheme called Bold, where they're allowing more decentralized watchtowers, but I couldn't find a single statistic about how many people actually run it, how many are there. So maybe there are still 13. who knows? If someone can find the statistics, please share it with me. I'll be happy to actually see it. The other thing is the watchtowers, even if decentralized, they're very poorly incentivized because you're only making a profit if you find fraud, but fraud is very rare, and you're not even making that much of a profit. So you're running this watchtower for God knows how long, maybe months, maybe years, in the hope that one day you will get something. How long will you run it with no profit? A month, 2, 5, 6, and then you stop, and then everyone stops. And who is checking for fraud? You don't even know who is checking for fraud because they don't keep a registry of all the watchtowers. So it's a bit of a, wishy-washy, we hope it works system, in my opinion. It has some nice properties, but there are definitely some trade-offs. Okay, that's it about the optimistic rollups. Now we are going into the ZK stuff. So how is the state managed? Pretty much the same thing. It's separate nodes managing separate rollup state. It's just rehashing of the same story. So how is execution validated? This is a bit more interesting. A lot more stuff is happening here. So first of all, ZK rollups are using very, very fancy cryptography that I will be not diving into. But the idea is that you can spend a lot of energy and a lot of effort to essentially provide a very, very small, succinct proof of an execution, proof of a transaction that then can be cheaply verified on-chain. It's expensive to do it, but from the perspective of the L1 validators, it will be very cheap to actually verify it. So the main nodes here will actually be the sequencers. This is the same as in optimistic rollups. They are the ones gathering transactions and posting them to L1. Validators on L1, same as before, but we have a new person here. Instead of the watchtowers, we have the provers. The provers are generally the nodes that actually look at all the transactions on the rollup and try to generate this short proof that can be posted so it can be quickly verified. The problem is it requires a lot of compute. And by that, I mean just running a transaction is like 2 million times faster than generating a proof for it. So there's a huge overhead for every single transaction that needs to be verified as a ZK. That needs to get a proof as a ZK. But there are some good things. So the main thing is it's also very, very, very light on L1 validators. The proofs, if generated, are super quick and they're deterministic, verifiable, super transparent. You see what's happening. Maybe the transparent has a caveat. It doesn't have to be transparent. ZK stuff allows to use a lot of cool primitives to actually keep it pretty anonymous. This is, I think, one of the coolest things about ZK, that you can have pretty hidden execution. You don't exactly know what it does, but you know it's correct. And it's pretty light on the data availability layer. Some of the bad stuff. So I mentioned that the optimistic rollups are a bit immature. ZK stuff, even more immature. They're still going strong, and to be fair, it's a really hard thing to do, so I think they're doing still an amazing job. But there are barely teams approaching stage 1 level, not even talking about stage 2. So as I mentioned, the biggest downsides, obscene proving costs. It's, if you care about, the planet not burning, then spending 2 million times execution, probably not the best. If you care about low fees, probably not the best. There are many perspectives from which you can look at it that make it expensive. And there are some, just to be clear, there are some initiatives to make it cheaper, but the most popular initiative to make it cheaper now is to just subsidize it through governance. And this is a very short-term benefit. They can do it for a while until the coffers actually go empty. The other problem is that we cannot really the ZK is so specific, we cannot do proofs for everything. It's pretty decent for simple transactions, asset swaps, but it's actually struggling with very generic compute. You have to create quite complicated ZK circuits. It's even more expensive to do. It's hard to develop. There's a lot of problems in terms of development that actually show up in here. And there are also a few ugly things. Because it takes so much energy and money to actually generate the proofs of chain, it's a strong centralizing force. Economy of scale comes into play. You're running a huge data center, generating the proofs for the whole ecosystems. And if all the proofs are coming from a single data center that is generating the proofs, well, probably not such a good thing. And this might be a really big problem. And the data on where all the provers are is a bit hazy nowadays. And some of the ZK chains are just running their own ZK prover, a single one by the company developing it, and that's it. Okay, and now we can take a look at cynical rollups. So some of you know cynical rollups, parachains before, alternatively Polkadot rollups, but I kind of like cynical rollups. It's detached from Polkadot. It's a generic term we can use for this overall technology. It can be also implemented in different places. So cynical rollups are pretty much optimistic rollups, but better with a lot of extra stuff. Mainly, they can be a lot cheaper, faster, and much, much safer because of explicit checking. I'll talk about in a second. How is state managed? Spoiler, the same way. Validators separated, state is managed separately on the rollup and on the L1. Nothing new here. But in this case, we pretty much have two node types. We just have the L1 validators and the sequencers. There is no longer the third family. So for the monolithic chains, as I mentioned probably 5 times by this point, the motto was check everything explicitly. Everyone checks everything. For optimistic, it was pretty much check nothing explicitly and just hope someone disproves it. And cynical rollups are kinda in the middle. It's about dynamically adjusting the number of explicit checks based on the assessed risk. But there is always some checks. So we always have some guarantees very quickly, actually. We don't have to wait 7 days, some quick guarantees that stuff is being done correctly. And doing some explicit checks, not waiting for a random watchtower hosted by God knows who to check it, we have very predictable and safe ways to guarantee faster finality. And much, much better security. No longer you have to wait for 7 days of a challenge period and hope that someone actually gives us the fraud proof. You can jump from L2 to L1 in probably less than under 18 seconds. So some of the benefits are actually even before benefits, like 10 of the 20 top rollups are running on Polkadot. They are cynical rollups is the main takeaway here. They're actually using that technology. Some of the people here are from Frequency, Energy Web, and of the others, so you can probably chat about their experience with cynical rollups and parachains. The big benefit of the cynical rollup approach is that it's super energy efficient. For instance, when you have 1,000 validator securing a cynical rollup, a single transaction is usually verified only by 30. There's 30 re-executions of the transactions. I think 30 is a fair bit lower than the 2 million of the ZK stuff. Like if ZK would be on this chart, it would probably go even above the top of the screen. So the main good things is no more challenge periods and actually quick finality going up, down, and sideways any way you want to bridge. And cheap compute, as I mentioned, only every single transaction is usually executed by 30 out of 1,000 nodes. We're actually being very conservative, but still giving us enough security. And it has an easier setup, only sequencers. You don't have to worry about watchtowers. There are, of course, some bad things. Reorgs can still happen, and this is something we are working on to eliminate this source of randomness. Things like Safrol will help with that, and we already have some sequencer settings that help mitigate that. But it's still a work in progress. There is no out-of-the-box anonymity like in the ZK stuff. You have to add it manually, not the easiest thing to do, doable, but it doesn't come naturally. And it does put a noticeable strain on the DA. There's a lot of stuff you have to put there. There are also a few ugly things we don't really like talking about, like the liquidity and state spread around too many rollups. Fragmentation. Hopefully, this is something that Polkadot Hub will maybe address, trying to centralize some of the stuff in a single rollup, make it easier to use. And then also Jam, that tries to have a big decentralized lake of data that allows for a more coherent interactions. But that is pretty much it for me. I think I'm on time anyway, but if there are any questions, then I'm happy to take them. Or I'll be able to be afterwards to have a chat one-on-one if you want.
Hello, hello. Let's do one quick question. It must be good. A good question. Over there. No pressure. You can think about it while I walk. Go.
Hi there. Thanks for the talk. Very good. Is there any technical reason why there are no cynical rollups on Ethereum?
Yes, there is a bit of a technical reason. I was actually thinking about it today. How hard would it be to have a cynical rollup on Ethereum? I need to think about it more, but it's not trivial. And the reason why it's not trivial is that rollups in Ethereum, even nowadays, are second-class citizens. Fundamentally, Ethereum is still kind of favoring just normal transactions, and they are slowly moving into this, okay, there's a designated amount of memory and DA just for rollups. So they're slowly accepting it. Cynical rollups kind of require like a first-class citizen relationship. They need to be the priority for the validators to verify. So it would probably require some actual changes to how validators operate right now on Ethereum to have something like a cynical rollup. Maybe there is a way around it with some clever workarounds, but it's not a simple plug and play to Ethereum the way it is right now. It requires a bit more from validators. Because notice that the checks are not done by the watchtowers. They're partially done by the original L1 validators. And this is the point of conflict.
Good job. Great question. Let's give one more applause to Maciej.